So who's confused?
Me.
Okay, let's do the problem. It says here, are we talking about number 1?
Yes.
Okay, number 1, y equals x to the 1/2 power, because we would never do the other thing. It says here, A, find dy dt when x equals 4, given that dx dt is 3. So I need an equation that relates x and y.
Like y equals x. Or that?
Yeah. Yeah, that's for sure true, right? Okay. So since that relates that, so let's go ahead and take derivative with respect to what?
Y.
What?
X.
They give us dy dt and they give us dx dt. What should I take derivative with respect to?
X.
Am
I
saying
said
it
y
wrong?
and you said it was wrong, so it's definitely x.
T.
Okay. So he's getting it. So I gotta say this one more time.
T, okay.
They give me dx dt and dy dt. What should I take the derivative with respect to so I can use my information? What?
T.
Perfect, thank you. dy dt is equal to?
3. No.
What are we doing?
No, 2.
1/2.
It says 2.
I know. I'm taking the derivative here. Remember we have to do that first?
I guess.
X to the
Yeah.
negative 1/2
Oh, okay.
dx dt.
Yeah.
Yeah, remember that? Okay, now I get to plug the stuff in, right? Dx dt is 3. X is equal to 4, so that's 1 over the square root of 4. 1/2 equals dy dt, which is what I'm looking for. Am I making sense?
Yeah.
All right. So dy dt is equal to 1/2 times 1/2 times 3, which is 3/4. Now let's do part B. Yes. What? Go slower. What am I going to? What?
Resnick, you said dy dt was 3/4.
That's what I got. Yes. Now, using the same equation, I want to find dx dt when x equals 25 and dy dt equals 2. Mr. Balasek, since I'm apparently saying things weirdly.
Wait, say that question again.
Let's do part B. Part B, I want to find dx dt when x is 25 and dy dt is 2.
Alright, so we go.
We need to find an equation that relates x and y.
So, wait, is it the same equation?
Same equation. So I'm going to take the derivative the same way. So can I start here?
Yeah.
Okay. dy dt is 2. 1 over what's x?
Alright, so now we got 2 equals 1/2 times 1 over root 25.
Love it.
And then times that by dx dt. So 2 equals 1 over 10.
You're already jumping ahead of me. I'll catch up to you.
Divide that by just kind of bring it over, so it's going to be 20 equals dx.
Doable? Makes sense? Relatively not bad? This should be a moment where you're like, oh, these are easier. I like these. Okay, go ahead and do 3 then. Warning, it's x times y, so we're going to need a little product rule time.
I have a question.
Yes, sir.
Why does sometimes we put it as x dy over dt, and then sometimes we do dy over dt, or dx over dt? Like in the problem before, when we found the derivative of y, we just did dy over dt, but here we're doing y dx.
So there are 2 things multiplied together, correct?
Yeah.
So I'm supposed to use a product rule, aren't I?
Oh, okay.
So I'm doing x times the root of the second part plus y times the root of the first part.
Okay.
Yeah. And then dy dt, I'm looking for dy dt, so okay, I don't know that. X is 8. Dy dt, I don't know. Then I run across it's y. I don't know what y is. Oh no. We'll get that in just a second. And then and then I've got dx dt is equal to 10 equals 0. Now, I don't know what y is. So this problem's undoable unless I figure that out. You make out how to figure that out? Yes, sir.
Plug it into the equation.
Plug it back in the equation, right?
Yeah,
When x is a, y is the x. What am I doing? 8 times y equals 4. So what's y be equal to?
Half.
1/2. Plug my 1/2 in. I get 8 dy dt's is equal to 1/2. No, it's not. Oh. Slow down, move too fast. Gotta make
So,
Resnick,
Yes, sir.
root of tan is 1 over cosine squared x, right?
Yes, sir.
And this one.
Fourth quadrant, right? So I go all sad tigers cry. So cosine's positive there.
Wait, can you run me through that? We learned that.
All sad tigers cry. Which quadrants are cosine positive and negative?
Oh, it's going to be positive in the 1 and 2.
Not cosine. Cosine is positive in the first and the fourth
Oh, right. Okay. First one. Okay.
for cosine. Does that make sense?
Yeah,
Is that
so
part of me?
positive.
So since cosine is positive, the thing's going to be positive. What's cosine of pi over 3? The roughly not going to be the same.
Is it root 3 over 2?
No.
1 over 2?
1 over 2. So it's positive 1/2. So put positive 1/2 down here. Then I flip, skipped, and multiplied. Okay, we try number 9. You're going to have trouble with number 9 because it's too vague a question. But it's going to bother you, and it's going to make you sad. And that's all good. But in a little bit, you'll be like, oh, that's not so bad. I promise. It gets better. Number 15. Let's do it.
Alright,
oh, yeah, you're
so
right.
you just start off a is equal to pi r squared.
Because you're jumping right to the finish line. We'll try that out. See how it works. What do you got?
dA over dt is equal to 2 pi r dr dt.
What's the radius?
What?
What's the radius?
You plug in 3.
Plug in 6, don't I? Or 3. Wait, what?
6 and
No, 6
Oh yeah,
for the radius and 3 for the RDT.
You're
36.
So 36 pi, what's my units?
Units with centimeters per minute squared.
Centimeters squared per minute. Right? Because I'm an area.
Resnick area is always going to be squares.
Right. The units for area is how many square centimeters or square inches or square feet or square miles, square whatever. Right. How many squares of this by this fit inside your box? All right. So for 17, 17a says, show that the area of the triangle is given by a equals 1/2 s squared sine theta. Honestly, it's a good problem. It's worth doing. It's worth learning how to do it. It's kind of fun to play with. But let's just say instead it says, hey, the area of a triangle is given by a equals 1/2 s squared sine theta, which has two sides that are equilateral. of a triangle. So therefore, B, try to do B now that you know that pertinent piece of information. And C, by the way.
Oh, I see one as always others. No,
Oh, I did. It was in fact law. Okay. All right.
All right, walk me through it. Tibbins.
Okay. So,
What do I have?
the rate at which it's changing.
It. Use the word, any word but it.
The spherical balloon.
Eh.
Oh, I don't know.
Says cubic centimeters. So what is changing?
Volume.
Volume. So dV dt, my volume is changing at 800 cubic centimeters per minute. Agreed?
Yes.
Okay. What else do I know? For part A, my radius is 30 centimeters. What do I want to know?
The dr over dt.
All right. The equation that writes volume and radius. Do you have any equations that write volume and radius? This one here, of course, they don't expect you to have that memorized, so they have to give it to you in some fashion or another. That's good news for you. Once in a blue Monday, I actually expect you to memorize that. Like, well, that's weird. It's rare. It hasn't happened in 10 years. So my guess is that's a thing of the past. Okay. What do we do?
dv over dt
dV dt
equals 4/3 3r dr.
Love it. So that's 800 equals 4/3 pi 3. My radius is 30 for the first part of the problem. Squared dr dt. That's what I'm looking for. 800 over 3600 pi dr dt. Or if I chop out some zeros and remove the 8, 2, 4, I'm thinking of 4 from top to bottom, so that would be 2 18/9. Units? Pi on the bottom, yes. Units?
Oh, centimeters per minute.
Per minute. There you are. Can we do that now? So I feel like something we can do, assuming you had that equation available to you somewhere. Ms. Tippins?
Yes.
Is that doable now? Good.